Today we are going to talk about the most important formula in finance. Most of our income and most of our expense are periodical. We receive salary every month. We receive pension payments every month. We pay rent every month. We pay back mortgage loans every month. We pay tuitions every term. Companies distribute bond coupons every 6 months. Banks receive mortgage payments every month or every 2 weeks. Even when incomes and expenses are not strictly periodical, the periodical payments are good first approximations. Business income may not be constant every year, but as planners, we often assume they are constant or change by a certain percentage every year. This will greatly simplify our planning. It is very important to measure the value of such periodical payments. We will derive this formula and apply it to many different situations. We have learned this formula before, but many of us don't feel comfortable using this formula. We will derive the formula together. This will make us more confident about it. More exercises will help us gain greater proficiency. We will apply the formula to many different problems. First, we will look at the simple case of constant cash flows. Suppose there is a constant cash flow distributed at the end of each time period. This time period can be daily, weekly, monthly, quarterly, yearly, or any other time interval. The distribution lasts for n periods. Suppose the discount rate is R. What is the present value of this cash flow? This is a graph of constant cash flows over n period of time. At the end of each time period, the amount of payment is D. The present value of the cash flows should be represented by Formula 1. Each payment is discounted by the discount rate, compounded by the number of years. To find out the formula for the present value, we multiply 1 plus r to both sides of the equation 1 to get equation 2. Equation 2 minus equation 1, we get the following. After rearrangement, we have the formula 3. This is the formula for the present value of a constant cash flow for n years or any other n periods of time. When n approaches infinity, the above formula becomes the formula 4, that is S equal to D over R. This formula becomes especially simple. Next, we will consider the present value of cash flows change at the rate of G. The present value of cash flows should be the following formula. To find out the formula for the present value, we multiply 1 plus r over 1 plus g to both sides of the equation 1 to get equation 2. Equation 2 minus equation 1, we get the following. After rearrangement, we have the equation 3. This is the formula for the present value of a cash flow change at the rate of g for n years. When n approaches infinity, the above formula becomes S equal to d over r minus g. Applications. These formulas have many applications. We will give some examples in the next slideshow.